Thank you all for joining us for today's Azure Series webcast, Windows Azure Storage, presented by Michael Collier. My name is Amy Nelson, and I'm the Marketing Coordinator for Neudesic and the moderator for today's webcast. This webcast is presented by Michael Collier, Neudesic's National Architect of the Windows Azure practice. We are very excited to have him present for us this morning. Today's webcast is part of our Azure Series. We will be hosting the next webcast, Windows Azure Role Communication, on February 8th. We will be sending out more information about this webcast along with the webcast recording. If you are logged on, you should all be able to see the title slide that states Neudesic. There was a brief intro earlier regarding features within live meetings. To briefly recap, we encourage you to ask questions throughout the session by typing them in. To ask a question, click on the Q&A verbiage located in the toolbar on the top left side of your screen. Type your question, then click the Ask button. Please note that all questions will be held until the end. We will also be using the seating chart feature within live meeting. Changing your feedback color within this tool provides feedback to the presenter. To provide feedback, click on the feedback menu found in the upper right-hand corner of your screen. Select your feedback color. Your seat in the conference center will display your selected color. Lastly, this webcast is being recorded and will be available via the Neudesic website. We will email you when the link is available. If everyone is ready, please make sure your seat color is green. And at this time, I'd like to turn our presentation over to Michael.
Thanks, Amy. So my name is Michael Collier. I am the Windows Azure National Architect for Neudesic. And what that basically means is I get to work with customers across the country on their Windows Azure projects. This can be helping with architectural design sessions, cloud assessments, training for architects or developers at the organization, and some evangelism efforts as well. Basically anything that relates to Windows Azure. If you want to get a hold of me, my contact information is here on the screen. You can reach me at michael.collier@neudesic.com. I'm also on Twitter and my blog at michaelscollier.com. So just to kind of recap on or go over some of the things we're going to talk about today, I'm going to kind of do a quick level set on Windows Azure, just so we have a kind of foundation to build on when we talk about how we're going to manage this platform. We're going to then talk a little bit about the Windows Azure Service Management API, the native API being a REST API. We'll then see how we work with PowerShell commandlets, which are a really great way to work with the service management features that Windows Azure offers. Cover a couple of scenarios where these the Service Management API could be useful, and then we'll leave some time at the end for any questions. So just kind of a quick overview of what Windows Azure is. Windows Azure is a really flexible and powerful platform for developers. You can build a lot of different types of applications on the Windows Azure platform, deploy them. They're deployed to Microsoft data centers worldwide. There's 6 data centers. There's 2 in the United States, 2 in Europe, and 2 in Asia. And you can really, nice thing about the Windows Azure platform is it removes the management features of the underlying infrastructure from you, and kind of lets Microsoft and the Windows Azure platform really handle all the infrastructure pieces that would typically go with deploying applications and running a data center. So you as a developer just have to worry about the application management features, application management for your service. You know, what you want to do, focus on the bits, and kind of leave the underlying metal, the infrastructure to Microsoft and the Windows Azure data centers. You'll use a developer SDK to write your applications for Windows Azure. There's SDKs available for most major languages today. There's obviously a .NET SDK. There's also SDKs available for PHP, Java, Node.js, and other languages as well. So you can pretty much run anything on the Windows Azure platform that you can run on a typical Windows Server system. With Windows Azure, you have a lot of on-demand services available for you, and kind of pick which services you want to use to build your application. There's compute services. These are typically your web or worker roles. They'll help host websites or just kind of back-end data processing applications in your compute roles. Windows Azure has multiple different types of storage solutions available. There's Windows Azure, I'll call the core storage services. These are your tables, blobs, and queues. And there's also SQL Azure as well. So if you need a relational database, you have SQL Azure available. There's networking features in Windows Azure Traffic Manager and Windows Azure Connect. Windows Azure Traffic Manager is basically a global DNS system that can really help you route application traffic to the appropriate data centers worldwide. And Windows Azure Connect lets you do have a hybrid connectivity with your application. So if I need to put part of my application on-premise and another part of my application in a Windows Azure Data Center, I can use Windows Azure Connect to enable traffic to flow between those two systems. There's identity management with access control services. Access control services is a federated identity solution that allows you to use Facebook, Windows Live, Google, Yahoo, and Active Directory to have an identity solution for your application. So I don't have to write to each of those APIs, those different providers. I can really just focus on writing to access control services, and I can use configuration to worry about how I'm going to work with those other identity providers. It becomes a very easy way to set up a federated identity management within your solution. There's also a caching service available as well, very similar to what you may have used on premises with Windows Server App Fabric caching. At the API level, it's very, very similar. The Windows Azure caching gives you that cache as a service, that distributed in-memory caching available in the cloud. So ideal situations for Windows Azure would be those areas where you need scalability, where I need to scale up very quickly, also scale back down when the need arises, or you have maybe some unpredictable spikes in traffic, or it could be predictable spikes in traffic certain times of year where you need to scale up to manage those resources efficiently. Windows Azure fits great in those situations. If I need to worry about availability, where I don't want to go down, I don't want to worry about how I manage any uptime or downtime or any hardware failures that may occur, Windows Azure kind of alleviates that from me as well and puts that off onto the platform. And that goes kind of along the same ways with our fault tolerance statement here. That Windows Azure has a pretty good fault tolerance story as well. On the storage side, you have 3 replicas of your data available. So kind of give a quick diagram of what Windows Azure looks like kind of in one slide here. We have, and then inside the Microsoft data centers, everything is deployed at those 6 data centers worldwide. You as a developer will probably start at the business portal, which is at windowsazure.com. It's where you're going to kind of learn about Windows Azure, get the marketing overview, get the kind of platform introduction to it, how you pay for it, pricing, and that type of stuff. From windowsazure.com, you can jump right into the developer portal. The developer portal can be accessed directly if you'd like at windows.azure.com. And the developer portal is going to be for developers their main interaction with Windows Azure. From there, you can manage just about everything on the Windows Azure system, all your services, your compute services. You can manage SQL Azure, access control services, all sorts of stuff from there. The developer portal actually uses a service management API, which is what we'll be talking about today. And the service management API can reach down and touch the storage cluster, so our tables, blobs, and queues. And it can work with our compute clusters as well, those being our web roles and worker roles. The service management API, its native interface into that, is a REST-based interface, so it's real easy to work with from a multitude of different devices and platforms. Just as the storage services have a REST API, REST interface as well, that's their native interface. From our desktop, we can use Visual Studio tools for Windows Azure. Those tools will give us a compute and storage emulator that we can work with. There's also a Windows Azure SDK, like we mentioned before, for multiple different languages that we can talk to our storage services, our compute services, and our service management API using on our desktop or dev tools. Within these individual nodes in the Windows Azure data centers, we're going to have our VM. We have anywhere from extra small to an extra large VM. And on those VMs, we have our code. Those are our bits, our application package that we're working with. There's a runtime API and a kind of a VM setup, the underlying virtual machine platform that Microsoft manages in the Windows Azure data center. So we really just have to manage our application code and let the platform deal with everything below that. For us today, we're going to be talking about the REST interface into the Service Management API. So some kind of key terms you'll need to know when working with Windows Azure, and especially the Service Management API. You'll see these terms come up quite a bit when you work with the Service Management API. A subscription is an account, and a subscription is really how Microsoft handles the billing aspects of Windows Azure. You also have a storage account. The storage account is your tables, blobs, or queues within a Windows Azure subscription, and you can have 0 or more storage accounts. You have a hosted service. A hosted service, the term there really means it's a container for your deployments. It's for your compute roles, your web and worker roles, and you can have 0 or more of those, and you can have one hosted service can use multiple storage accounts if you want. A deployment in Windows Azure is a running hosted service, and that can be deployed to either a production or a staging environment. And those environments, the production and staging environments, are almost exactly the same. They're the same at every level in the machine and infrastructure level. They're the same there. The only difference is a DNS change. A staging environment has a GUID essentially as the prefix to the URL, so it's kind of security by obscurity in some ways there. It's not going to be easy to find. Whereas your production URL and your production environment is going to be something a little more friendly, maybe like, mycompany.cloudapp.net. You will need an X509 certificate as a management certificate to work with the Service Management API, and we'll see more on the certificates coming up. A location, Microsoft will say, well, I need to work with a deployment in a certain location. It's going to say which one of these 6 Windows Azure data centers do you want to work in. You also have the idea of an affinity group. And an affinity group in Windows Azure is a logical used to describe how your hosted services and your storage accounts are deployed within a Windows Azure data center. Typically, you want to keep your hosted service, your compute instances, as close as possible to your storage accounts. And an affinity group lets you do that and say, I want all these services to be together as close as possible within that data center. An operation is, just like it sounds, it's a management operation against the storage management API. You can see histories of those at the API if you want. And there's operating systems. It's really, with Windows Azure, you have multiple different operating system versions. You'll see referred to as an OS family. There's 2 OS families, OS Family 1 and OS Family 2. Those really relate back to the core system being Windows Server 2008 or Windows Server 2008 R2. And then as Microsoft releases patches to the operating system, does updates to them, you'll have OS versions that go along with that. So the management options, how do we manage our Windows Azure services? Well, there's several ways you can do that. One, probably the easiest way for developers to get started with, what most people will get into right away, is the developer portal at windows.azure.com. You'll use your Windows Live ID to log into that developer portal. And from there, you can manage basically anything with Windows Azure. If you need to grant access to another person in your organization, you can do that by granting a co-admin. A co-admin has exactly the same rights as you do. They're a co-administrator, so they can do basically anything with your instances. So you want to be careful, what type of support or what type of who you're giving these access to, because they do have quite a bit of power. A lot of enterprises, though, will kind of move away from the developer portal instance when they get into the management side, just because of having to rely on Windows Live ID and wanting maybe a little more enterprise-friendly solution to do that. So we'll look at tools such as System Center Operations Manager. There is a management pack for Windows Azure that you can deploy to System Center Operation Manager. So if you're a SCOM shop, that could be something you definitely want to look at. Developers can use Visual Studio. There's a little bit of tooling in Visual Studio now that you can work with to manage your services, your hosted services, and your storage accounts. And there's also, if you like MMCs, the management consoles, you can download a Windows Azure management console from Coplex. There are some third-party tools as well for working with Windows Azure. Cerebrata and Quest Software both make great tools on that side. Cerebrata, as I've used before, on their Storage Studio and their Diagnostics Manager, those work pretty well, and Quest Software just has some really nice cloud tools as well. If those don't kind of fit your needs, you're certainly welcome to create tools that really do fit your needs, and the Service Management API gives you that ability to create basically anything you want to work with Windows Azure, and what we're going to look at today is using that Service Management API. So let's dive into that a little bit here. So what can we do or what can we not do with the Service Management API? There's a lot you can do with the Service Management API. If I want to manage my hosted services It's creating new hosted services, updating them, starting them, deleting them. Basically, any sort of action you can think of against a hosted service you can do with the Service Management API. Same idea with the storage accounts. I can also work with my certificates there. So if I need to upload a certificate for working with an SSL site, I can do that. If I need affinity groups, if I want to create new affinity groups or list those affinity groups, I can do that through the API. I can also see which Windows Azure data centers are available, what are the location names. That could be useful for situations where you're creating your own UI and you need to build out a tool that says, hey, I wanted to do something to a particular instance. I need to know what the locations are. So I can call the list locations feature to pull back what are the official names for the locations. Right now there are 6 Azure data centers, but you maybe see that may change sometime in the future as Microsoft continues to roll out the Windows Azure systems. If I want to see information about the operating system, like which version am I on or what are some features of that operating system, OS information, I can get that. Just so I can look back at my subscription and see what are the different operations that were taken against a particular subscription and see what my quotas are, if I'm reaching a certain quota or not. Am I using too many hosted services running into the max there, or storage accounts, CPU, stuff like that. The platform does have some quotas, mostly soft quotas that you can run. You can get all that type of information from the API as well. There are a few things that you can't do from the Service Management API, and one of the things is creating a subscription. The API doesn't let you create a new subscription, and you have to go through the portal to do that. That's mostly because we want to make sure that people who are signing up for Windows Azure are humans in some ways. It's making sure you're 18 years old or older and have a credit card, so they don't have to put a credit card in just to verify that you are not a bot trying to do anything malicious. There's also no billing API right now within the platform. So the Service Management API does not let you tap into the billing systems in any way. You'll still have to go through the portal to see that. And this API, the Service Management API, is a little bit different than what you'd work with on the SQL Azure or Access Control Services side. There are APIs, there are REST APIs for both SQL Azure and ACS. This is not that API. There are different APIs, all very similar. They are different ones. So if you need to work with those, you'll have to go to those specific APIs. Versioning. Microsoft will roll out different versions of the Service Management API as they continue to update the platform. It's pretty nice, so you can keep working with certain versions if you want, but if you want to work with the new versions, take advantage of new features, you can certainly do that. You will need to specify a request header, and that request header is x-ms-version. You have to put that as a request header, and then you'll need to specify the date that goes along with that. The most recent version of the Service Management API is the October 1st, 2011 version. And that really was a minor update to the version, but it did add new features to allow you to roll back or upgrade an operation. So previously, if I was deploying something to Windows Azure and I detected that there was a problem in some way and I wanted to roll back to previous version, my only real solution was to wait for that operation to complete, then issue a delete, and then do an update at that point to pull that version back in the previous version. Now with the rollback, there are certain points along with in the update process that a rollback is a valid action to take, and I can simply issue that rollback command, and the operation will stop and revert back to the previous version. So it makes it a lot easier for you to do those type of rollback operations. If I want to get information about my subscription, that is a new feature that was added in October as well. And then a couple updates happened along with the Get Hosted Service Properties and Get Deployment Methods. And that really returned more information, much richer data coming back from those APIs now. On the security side, how do we authenticate when using the Service Management API? You will need an X509 certificate. You can create those certificates on yourself. They can be self-signed certificates. You do have a maximum per subscription of 10 certificates. You will not be able to upload any more once you reach 10. So keep that in mind. You do have a limit there, so you don't want to go creating a crazy number of certificates. The certificate that you upload to Windows Azure for that management certificate would not contain the private key. You want to keep that certificate, this X509 certificate that you have, on your machine or your whatever management server you're working on. You want to make sure you keep that secure. That key that you contain will contain the private key. And if anybody does have access to that private key for that certificate, they can do basically any operation against your services. So obviously, just like you would want to maintain some sort of security around any other certificates you have in your enterprise. You want to keep that same level of security when working with the Windows Azure management certificates. You will need to use HTTPS. You have to go over security. You want to make sure that this API is a pretty powerful API. You want to make sure it's as secure as possible. And like I mentioned, you can use self-signed certificates if you like, and it's great for development purposes as well. Self-signed ones is really a certificate between your instance, your machine, and Windows Azure, so self-signed certificates do work well there. You can use IIS. IIS is certainly the easiest way to create a self-signed certificate. If you're a command line junkie, the MakeCert part of the SDK will help you with that as well. And if you're working with Visual Studio, there's an update in the latter part of 2011, around the December timeframe. They made it real easy to actually go in and create a certificate and install that onto your machine. The new publishing wizard will walk you through all that process there. You'll get a certificate that's imported into Windows Azure, and you can import that into your machine as well, so that makes that process real easy. So let's take a look at the REST API here. So we got to get some of the basics out of the way. Let's look at some of the core features with this API. You're basically going to start at the endpoint level at management.core.windows.net, and then specifying your subscription ID. Most other operations will really kind of tail on from this basic endpoint. Windows Azure is going to be your friend with working with this service management API on the REST side. MSDN has a lot of really good information. I definitely recommend going there, bookmarking that page. I've created a bit.ly for you there at bit.ly/Azure Service Management Ref MC. You can go there. It's the home page for the Service Management API. Bookmark that. You can dive into a lot of examples and situations where you can use the API. They do a really good job there. Just something to keep in mind that you'll see coming up when we get to the PowerShell side, but when you're working with the REST side as well, something to be aware of that there are async calls with the REST API. You'll need to pull that API to find the status of the service. So once you issue a certain request, you'll hopefully get back a 202 and accepted. That doesn't mean that your API call succeeded. It just means that the server got your APE request and is working on it. So you'll want to pull that to find the status. You don't want to pull too frequently because you may get throttled. So just kind of pull every second or two, couple seconds, and you should be okay. So let's take a quick look at creating a new hosted service using the Service Management API. I'm going to switch over to my desktop here. And so we should see here on the screen the Windows Azure Management Portal. This is at Windows Azure or windows.azure.com, and we're going to create a new hosted service in the subscription here, this special subscription. It's going to be a Favorite Ninjas hosted service. And you see I don't have a Favorite Ninjas service here. So we're going to jump over to Visual Studio, and I'm going to walk you through some of the code that does that. Just in the interest of time, I'm not going to make you watch me write code. I think you can kind of follow along with this and see how that works. So we're going to start here. We have our thumbprint. This is our management certificate thumbprint. I've already gone ahead and installed a certificate on my machine and have that certificate on Windows Azure Management Portal as well. And the subscription for my Windows Azure account. So let's just go ahead and walk through this in the debugger so we can kind of see how everything is working. So I'm going to go over here to my solution. And we are going to make sure we are walking through this project. Okay, so create hosted service. We're going to specify what is our service name. A service name in this case is really the DNS prefix for our hosted service that we want to create. So everything's on the internet. We're going to create a new hosted service. So this one will be at funnyninjas.cloudapp.net. We're going to give it a label. A label is really a friendly name that we can see in the management portal. So when we're done here, we should see a Funny Ninjas 2012 label. And we're going to deploy this to the North Central US Data Center. So if we step into this service here, down, so hopefully we can see this. The first thing we're going to do is go ahead and create out our request body. This is going to be sent over an HTTP post, this text here. It's going to specify our service name, our service label, and location. And the ordering is important. MSDN will kind of show you what properties are required and optional. And these are the minimum set that you would need for this operation as well. Get that, and here's our service management API endpoint. So it's management.core.windows.net. We're going to pass in our subscription ID along with services. It's going to be a hosted service is what we're going to be working against. And then we're going to go ahead and create our request. So if we step into create request, we can see one of the first things we need to do is we need a management certificate, our X509 certificate for our thumbprint. So we'll step into that code here. This is not a lot of code in this section here. All we're going to be doing is looking at our certificate store. We're going to look at my personal store for my user. I'm going to open up that certificate store. And I'm going to attempt to find this particular certificate, find it by thumbprint. We're passing that thumbprint in. If we get a certificate coming out, so we got a certificate there, we're going to pull that certificate. We're going to make sure we close that certificate store. And we're going to return that certificate back. Now that we have our management certificate, we're going to go ahead and create our web request. And we're going to specify that version. Remember we said we had to specify a version along with the request. So we're going to specify that. This is the most recent one in October. We're going to do an HTTP post, specify that. And we're going to go ahead and attach that management certificate to our web request. So now we're going to basically issue that request. We're actually going to have to write that body out, excuse me. So we're going to get a request stream. Using that stream writer, we can go ahead and write out our request body. So the message we built up here at the top of the screen, I'm going to write that out to the stream. And now we can go ahead and get that response coming back. So if everything worked here, we should see that our response status code is created. So we know that we did get that Service Management API did get ahead and receive our request. And this code in this section you see here is really shown for demonstration purposes. The Service Management API does not really return a response body for the create hosted service method. But if it did, you could go ahead and get that as well. So we can see here we didn't actually get any response back as a body, which is good. So we need to end this guy. And if we jump back over to our management portal, we should see, yep, a Funny Ninja's hosted service was created. There's no roles in here yet. We've just gone ahead and created a hosted service at this point. You can see on the right-hand side of the screen, we have our DNS prefix here. So we see that this is the same one that we actually did create, and it was created just a few minutes ago. Let's jump back over to the slides here. So that was the REST API. Let's take a next look at the PowerShell commandlets that we can work with. The REST APIs are really great, but there is more verbose code we have to write to work with, so they're using them in the right situations. The PowerShell commandlets are really great as well. The commandlets definitely are your friends. If you haven't downloaded the PowerShell commandlets, I would definitely recommend going, as soon as this webcast is over, and going out to the Coplex site at wappowershell.coplex.com and downloading the package for those. A couple of things to note about these that I think stumps people sometimes is if you're working on a 64-bit machine, the scripts to install the PowerShell commandlets do install the 64-bit version of the commandlets by default. That stumps people sometimes when they want to do build operations or work with Visual Studio. Visual Studio is still a 32-bit system, so you will need the 32-bit versions if you're running from maybe a build process, for example. So you can go into the PowerShell commandlets. There's a script in there you can run install util that will pull that in, and so you can install the 32-bit versions as well. I have both of them installed on my developer machine. Cerebrata also makes kind of a supplementary PowerShell commandlet, so they're Azure management commandlets. You can see their address there on the screen. And these kind of supplement what Microsoft has given with the Windows Azure PowerShell commandlets. So if you need some more features, you can use those commandlets there. They kind of bundle some things together and make it pretty easy to work with. The PowerShell commandlets are really a great solution for IT pros or your DevOps teams. They typically like working with PowerShell. This gives them a really familiar environment to work with, where they can really create nice, powerful scripts for managing the Windows Azure services that developers are deploying. Developers, a fantastic tool as well. If you don't know PowerShell, definitely spend some time learning PowerShell. Using the PowerShell commandlets for Windows Azure, you can save yourself a lot of time as far as just kind of going through the deployment process when you're working with Windows Azure or doing any cleanup or any operations. Create yourself a little folder, put some PowerShell commandlets in there. I think you'll have a lot of really good stuff to work with as a tool belt going forward. And CFS is something we've used quite a bit internally at Neudesic, is just using PowerShell commandlets for our team build processes to help us with our deployment operations. It gives us very nice scripts that we can work with to build our solutions and deploy those out to Windows Azure. So I think really the best way to get in touch with the Windows Azure PowerShell commandlets is really to walk through another demo of them. There's a lot of PowerShell different commandlets available, and we can see some of these and how we can go ahead and deploy a service to Windows Azure using these commandlets. So I'm going to jump back over to Visual Studio now. I'm going to close this window. So we've actually gone ahead here and I've created a very simple project. It's just a very simple MVC3 application that we have and a Windows Azure project here. So what I'm going to do is I just want to go ahead and build this project for me. So we're going to go ahead and build this. So everything built successfully, so that's good. So what we want to do is take this funny ninjas.azure cloud project that we have and go ahead and deploy this project out to Windows Azure. We want to deploy it using PowerShell. Now I could obviously deploy it using Visual Studio as well. If I wanted to do that, I could right-click on the cloud project and click Publish, and I would get a wizard that walked me through the process, as you'd see here. If I want to use PowerShell, an easy way to do that, I have PowerGUI script editor, which is a PowerShell tool that you can download from powergui.org. I found it works out pretty well. And so I think, again, the easiest way here, just to kind of save some time and so you don't have to watch me type out some code, is we'll walk through this PowerShell commandlet, PowerShell script, and see the different steps you have to take to deploy a Windows Azure package using PowerShell. I've set up some variables here at the top. Look in some ways very similar to what we saw on the REST side. I need to know what is my management certificate thumbprint. I need to know which subscription I'm working in. And I also need to know what package or what build path I'm working in. So this is the path that Visual Studio creates when I go ahead and build my solution. Or excuse me, actually I need to go back to Visual Studio. I built the solution, but I didn't package. I need to go ahead and package that solution. So I'm just going to click on Package here. And that'll let Visual Studio go ahead and package the solution for me. You can see it went ahead and created our CS pack file and our cloud configuration file that we need to work with our cloud projects. So now we have that. We say here is our package file that we just created and our cloud configuration file. We're going to deploy this to the Funny Ninjas service, and we're going to use a storage account that I've created in my name, Michael Collier. The storage account is necessary because the PowerShell script, when it runs, will actually go ahead and take your package file that we have here and our configuration file, and we'll upload those to a storage account, to that storage account that you specified. There is a VS deployments container and blob storage that these package files and configuration files get deployed to, and from there they're deployed to the Windows Azure engines. So I'm just going to print out a little bit of debug code saying here's everything that we're working with. So let's go ahead and just kind of step through this process so we can kind of see it work. So I say what certificate I'm working with. I'm looking in the current user store, and pulling in that thumbprint. I can say what certificate we're using. Make sure I can go ahead and get that certificate. So I'm using the get item commandlet to get that. So we were able to find that certificate. We skipped over the if block. And then here I'm just basically building up some parameters I can use going forward in the commandlet. So I want to know what package am I working with, where is that full path of that package, and you can see what the full path is and by just kind of hovering over these variables. Or is my configuration file. And then I'm going to define a build label, and I'm using the date timestamp to kind of build out this build label. So we'll see that my build label is the name of my hosted service, Funny Ninjas, and then a version which is very similar to the timestamp they're working with. I want to make sure that the commandlets are loaded. So I'm going to make sure that we have those commandlets there. If they're not loaded, I want to go ahead and add those. Now I'm going to check to see if the hosted service exists within the staging slot, and that's what this line here is doing. It's going to make a call out to the API, out to the service management, using the service management APIs under the cover, make a call out and get information back. So we can see here that we're going to go ahead and create a new hosted service. We're going to go ahead and deploy this application out there. So we need to create a new staging slot deployment. So we're going to do that. And this is one of those async operations that we have to work with here. So it's going to go ahead and these commands are going to go and upload the package to blob storage. And then it's going to sit there and wait for that operation to be complete. So that should take just a few seconds there for that to upload. Once that is going through, you can kind of see here we get that hosted service. When we work with the new deployment, we're going to create a new deployment in our staging slot. And as you recall, there's two slots, there's a production and a staging. And we're going to specify some of those parameters there. What configuration are we working with? What is our build label, the service name, and storage account? And then once we have that, should come back here pretty shortly. We'll go ahead and set that deployment that we had just created. Go ahead and set that deployment status to ready, because once we deploy, we have to kind of turn it on. So you can have a status once you can have a service up there that is not enabled by default, that doesn't turn on by default. So we want to go ahead and turn that solution on so we can work with it. So we've got that back. So we're going to issue a command here to turn that service on. And this is just some extra code I can show you through here that we're working with. I'm creating a new service, but there's already a service there. I want to go ahead and update that service, do an in-place update on that. And I can do that as well. I can simply say do an update deployment, which will go ahead and update that service, do an in-place update. If I don't want to do an update, I have commandlets that will help me do a complete tear down and redeploy as well. And that's what this block of code here is doing. It's suspending the current deployment, removing the current deployment, and then creating a new one as well. If we jump back over to the portal, we can see that we are starting to spin up a new Funny Ninjas deployment here. And then we just need to kind of wait for this thing to complete. So I will let this go. This is basically a while loop that's going to continue to pull that service to see when it's ready. The service is up and available. It'll take 15 minutes or so for that deployment to come online, because it is a fresh deployment of a new service. And once we're done with that, we will just simply write out that we're ready to go. So we can see here the Windows Azure is going ahead and starting to initialize and create our deployments for us. So we'll check back on this towards the end and make sure that that's up. In the meantime, we'll continue on with the slides. So a couple scenarios where Windows Azure Service Management API is really useful in the PowerShell commandlets is, like I mentioned before, I'm working with TFS. If you're doing a team build environment, you're using team build for deploying to your different production or staging or developer integration environments, using the PowerShell commandlets can be a great way to go in that aspect. They're pretty easy to work with. There's lots of PowerShell commandlets out there, a pretty big community working with Windows Azure and PowerShell to make some pretty nice things. To go over productivity, I think I mentioned this before, if you're not using PowerShell or the PowerShell commandlets for Windows Azure, definitely spend some time working with them, pull down some of the samples, and really kind of figure out some things you can do with those and how you can really increase your productivity. There's no sense in not having some of these tools available. They really do work very well on those. On the scaling side, the API becomes really a great tool for you. As you know, Windows Azure doesn't have a current scaling solution built in, so there's a tool from the Patterns and Practices team, part of the Enterprise library for Windows Azure Integration Pack, which you can create a quick little bit.ly here that'll help get you there faster at bit.ly/int-lib5 Azure MC. So hopefully that's a little easier to remember, and you can hopefully write that down during the webcast here. You can go to that site and you can read about Wasabi, the Windows Azure scaling application block for Windows Azure. The source code is available for this, as well as the reference API, reference applications. So if you really want to dive into seeing how you can use the Service Management API, the REST interface for this, I definitely take a look at Wasabi and some of the source code for that. They have a lot of really good code in there. Of course, if you want to do a scaling solution, you can write your own custom code using a variety of methods and using the Service Management API as a way to interact with Windows Azure, say, hey, I want to scale up or scale down solutions based off whatever my business needs may be. Some quick resources I think will be helpful in working with the Service Management API. One, if you don't have it already, I would definitely recommend getting the Windows Azure Training Kit. You can download that from bit.ly/Azure Training Kit MC. Go ahead and download that. There's an online version as well if you don't want to download it. It's a pretty hefty download, several hundred megs to pull that thing down. But they cover every aspect of the Windows Azure platform in the training kit, including using the Service Management API. So definitely pull that down as well. If you want a good book on just Windows Azure development in general, but he has some really good stuff on the Service Management API. Neil McKenzie's the Windows Azure MVP. He has a really great book out on this. You can download, or you can purchase that from packetpub.com. He's got a lot of good recipes in there on just using the Service Management API and the PowerShell commandlets. So definitely would check that out. Michael Washam works on the Windows Azure team. He works with the PowerShell commandlets. Follow him on Twitter or check out his blog. He has lots of good samples and tips and tricks on working with PowerShell with Windows Azure. And Tom Hollander is on the Azure Patterns and Practices team at Microsoft. I definitely follow his blog as well. He has a lot of good sample PowerShell commandlets, especially working with TeamBuild. There's a lot of good stuff there. The PowerShell commandlet that we demoed today, a lot of that really came from his blog, and that same PowerShell commandlet is pretty popular online as a sample on how you can work with PowerShell and Windows Azure. Tom has some great stuff on using, like I said, TeamBuild, TFS to do some pretty nice stuff with Azure, as well as definitely MSDM I mentioned before. It's going to be your friend with working with the REST APIs. You can get that at bit.ly/Azure Service Management Ref MC. I get a short link to that information there. So that's all we got for today. I want to see if we have any questions.
Great. Thank you, Michael, for this awesome presentation. We did have a few questions come through. As a reminder, to ask a question, please click on the Q&A verbiage located in the toolbar at the top left side of your screen. Type the question and then click the Ask button. One was, could you please share the resources in this webcast? Yes, we will be sending out a recording of this webcast, including with the slide deck as soon as we get all that together, so you will receive that. Another question that came through, what should be the strategy for minimizing the bandwidth cost when we interact with Azure platform via Service Management APIs?
Minimizing the bandwidth. I would try to do as much as possible in a single operation. I mean, the packages that you upload, that's obviously going to depend on what you have to work with. For large packages, I would definitely not deploy a large, like if you have a lot of images or maybe some executables, third-party pieces of your application that you want to deploy as part of your application. I don't know if I necessarily put those dependencies as part of your package file, but maybe more deploy them to blob storage as a separate process that keeps your service package file much smaller, makes it easier for you to update in that respect as well. So you want to kind of help on some of the bandwidth there. The bandwidth charge, it doesn't cost you anything to put data into Windows Azure. It only costs and you want to get data out. But it's more of a speed of upload time for those type of applications. Hopefully that kind of answered your questions.
Thank you. Another question that did come through. How do you think the job market for Azure developers?
Oh, I think it's definitely getting more and more popular. I'm a firm believer that Azure and cloud computing in general is going to be the way developers are going to be working in the next year, this year especially, and then going in the future as we get into more and more mobile solutions and cloud kind of really becomes more mainstream, I think you're going to see more and more developers gravitating to it. It's going to be, I think, a lot of ways the way a couple years ago, probably several years ago, you saw everybody wanted to be a web developer, and that was kind of the hot skill to have, as a website. Everybody's going to put web applications up. I think you're seeing the same boom starting for developers with skill sets in a cloud solution, whether that's Azure or even Amazon, Heroku, other cloud platforms as well, but definitely on the Azure side just as well. That's going to be one of those hot skills, I think, that definitely be in your best interest to have.
Great. The next question. Do we really need a REST API while Cmdlets cover the same functionality?
Good question. I think that it's really the choice on how you want to interact with the management API is really a choice, depends on your situation. The REST API is the native API. If you're working with a tool, if you're creating a tool, maybe a WinForm application or a web application of some sort, the REST APIs are going to work really great for you. There are some even mobile applications today that work with that manage Windows Azure, and they're using the REST APIs there. The Cmdlets are really just wrappers around the REST APIs. So if I'm working with Team Build, for example, Team Build, I can certainly write custom code and use the REST API to work with Windows Azure. But personally, I find the Cmdlets much easier to work with. So I'll write a PowerShell script to work with rather than writing custom code. So it depends on what kind of code, what application you're working with, which interface you want to work with, but everything still boils down to the REST APIs.
Great. Thank you. Another one. Will the code samples be shared?
They'll be a part of the stuff we can upload, and I can make them available on my blog as well. I can work with Amy to figure out a good spot for that information.
All right, perfect. Yeah, we will set together a email that will go out that will have the slide deck, the recording, and probably, Michael, your blog as well. All right. Let's see. Next question came through. Just out of the context question, how do we set up different environments on premises for testing the cloud application? For example, dev for developing apps progressively and SIT for QA team testing. What should be the right strategy for UAT environment? Should it be on-premise or in the cloud considering the cost associated? Will developer fabric help on premises to set up the environment?
Loaded question there.
Yeah, if you want to look at it, Michael, you can jump up where it says Q&A and you can read it.
Yeah, I think the real answer here is, for developers, most development can happen on your laptops. I do Windows Azure development, all the time, and I use my laptop, my emulators, compute and storage emulators, for almost everything. We have some teams that we're working with. We'll deploy to Windows Azure as kind of a quick integration environment because while the emulators do a great job of simulating how the system works, there's still really no substitute for deploying your applications to Windows Azure and seeing how they work. So we'll see organizations that they'll have one subscription that may be just for developers to work with, and they can control access to that subscription, they'll deploy stuff up there, turn it off at night, for example, to kind of help save costs. You can build processes around that. Maybe another subscription or another account, even hosted service that is for your QA team, and do the same thing for production as well. So you can really divide out the subscriptions and hosted service accounts, the storage accounts, based off of the development usage, whether it's for development, QA, production, or whatever environments you may have on that. So it's really, I do most of my development on-prem, but sometimes I do need to go to the cloud because there's certain scenarios that work only in the cloud. So it's really kind of, figure out what works for your organization, and I think you'll be pretty happy with that.
Perfect. The next question. I think more apps go to Amazon EC2 than Azure for .NET development. Do you see the same?
Amazon is probably the bigger name in some ways, of the 800-pound gorilla with cloud computing in some ways. For Azure, for .NET developers, or any development really, I think it's more of a change in how you write your applications in some ways. If you're looking, and what do you want out of your cloud deployment? Now, Azure is a different type of model. It's a platform as a service. If you're taking advantage of the platform and what the platform can do for you, Azure is a really great fit. If you just want a simple kind of a shared hosting environment, which is really what EC2 has in a lot of ways, is more the infrastructure side. Then EC2 kind of fits that model. So there's slightly different models on how they work. As a .NET developer, Azure is a very easy path for me to work with. The tool sets are all built into Visual Studio. Microsoft does a really great job on kind of making that ecosystem work very well.
Perfect. Another one we have, what if the Azure queues go down? Is it possible?
So I think that's really kind of targeting more not so much Azure queues, I would guess, and correct me if I'm wrong, but more about the Azure storage infrastructure overall, tables, blobs, and queues. And the idea there is that the Azure storage infrastructure is triple replicated within a data center. It's triple replicated for high availability. So you have 3 replicas of table storage, blob storage, and queue storage. So if there is a failure within that data center and some of the queuing infrastructure goes down, there's 2 other copies available for high availability purposes there. In the event, so you shouldn't lose any data once it's in the Windows Azure data center. So if you're asking if a data center goes down, what happens? It would be to have to take a pretty catastrophic event for a Windows Azure data center to go down. But obviously not unheard of, right? I mean, Amazon had an outage on the East Coast that was pretty got a lot of attention when they lost some of their data centers. And so far, thankfully, an Azure data center hasn't had a similar type of situation. But if it did, if there was some sort of natural disaster or something that took out an Azure data center, your table and blob storage is actually geo-replicated to a secondary data center within the same region. Queue storage at this time is not geo-replicated by default, but tables and blob storage is geo-replicated. So you have 3 copies in your primary data center and 3 more copies in a secondary data center. Microsoft would have to trigger a DR scenario, a disaster scenario, for that failover to happen, but they're taking care of that kind of DR situation behind the scenes on your behalf.
All right. If anyone has any more questions, please feel free to type them in at this time. In the meantime, I'm going to click through a few polling questions, and we would greatly appreciate your feedback. The first question, was this content helpful for your business? With a typo, yes or no? All right, give it just a few more seconds. All right, great, thank you. The next question, please rate the presentation content, excellent, good, or poor. All right, and the last question I have for you, would you like us to schedule a follow-up, yes or no? All right, well, thank you, everyone. We will be forwarding you the link to review a recording of the webcast along with the slides and along with Michael's blog. Again, thank you so much for everyone for joining us, and we look forward to seeing you on our next webcast. You are free to disconnect. Thank you.